In this video, we're going to look at topic 2, example 5, where we solve work and time problems. So Latanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair, and then she will ride her bike home. We're told that she walks at 3 miles per hour and can bike at 10 miles per hour. Can she be home in 1 hour? So this is actually a pretty complicated and involved problem this early in the year, but it gives us a good kind of um, taste of how to do these problems, and it gives us a good problem where everything gets involved. All right, we need to look at time, distance, and rate. We need to look at common denominators. We need to look at setting up linear equations and solve linear equations. So again, there's a lot going on. And I've mentioned in the previous video, one of the first things you should do is set up an equation using words rather than numbers. So we're talking in terms of time here, and there's 3 phases to this trip, right? Tanya's going to walk, then she's going to wait. So she's going to wait at the shop. Then she's going to bike, and that's the end of her trip. So she's going to walk from her house to the shop, she's going to wait at the shop, and then she's going to bike back home. And that's going to be the total time, right? That's our entire trip. And ultimately, we're trying to figure out if this part here, this walk, wait, and bike, is less than an hour. All right, so we want to know, can she be home in 1 hour? So what we need to do is we need to replace each of these parts, this walk part, wait part, bike part, and total time part, with variables, okay? And we need to plug in some numbers here. Now, later on in the year, we get to literal equations, but you're probably pretty familiar with the equation where distance is equal to rate times time. Hopefully you've seen that at some point. And what we're looking here is this is the time spent walking. This is the time she's waiting at the bike shop, and this is the time that she's biking. So we want to know what time would be equal to, and to do that, we can divide both sides by the rate and learn that time is equal to the distance covered divided by the rate of travel. So that's going to make this a lot easier to set this problem up because we want things in terms of time, not in terms of distance, not in terms of rate. When you figure out how much time passes for each section. So the time that we're walking, we're told that the distance, so we're looking at distance divided by rate, the distance we cover is 1.5 miles. And that's going to be divided by the rate that Latanya walks, which is 3 miles per hour. And that's going to tell us how much time she spends walking. All right, we could figure that out, and we'll do that in a minute. The time that she waits at the bike shop, we already know, they told us, she's waiting 30 minutes. So since we're talking in terms of hours, we're going to say 30 minutes is 1/2 hour. All right, and then we also need to add up the time biking. And remember, time is going to be equal to the distance divided by the rate. So the distance is once again that 1.5 miles because she's going the same way home. And this time it's going to be divided by 10 miles per hour because she can definitely ride her bike faster than she can walk. And when we add all of this up, that's going to be our total time, which I'm going to change and use the variable t in terms of time. So now we can get rid of some more words, and we can say that this is 1.5 divided by 3 plus 1/2 plus 1.5 divided by 10, and when we add those up, that will be the total time. So I know this isn't an easy setup, and this definitely isn't an easy problem to figure out this earlier in the year because you're not familiar with a lot of this stuff. So you may have to watch the video 2 or 3 times, and you definitely may need to ask questions about it, but just kind of take this as a challenge problem. Don't expect to understand all of this the first time you're going through it. There's a lot of pieces, there's a lot of moving parts. It's a very involved problem. So Now that we have all numbers and just that one variable, we can solve for the variable t. And there's a couple ways we can go about this. We have three fractions on the left. So we have 1.5 over 3, 1/2, and 1.5 over 10. So what we can do is we can add those up, we can combine them, or we can look to solve this. And what I'm going to suggest, anytime you have any type of linear equation with variables, sorry, not variables, with fractions, is try to get rid of the fraction as soon as possible. And the way you do that is you multiply everything by the common denominator. So we need to find a common denominator between 3, 2, and 10. And bear with me here, but you'll see in about 2 steps why we use specific numbers and how we can just get rid of all those fractions. One of the easiest ways to find a common denominator, and we're trying to find the common denominator between 3, 2, and 10, is to list the terms that the largest number goes into. So 10 goes into 10, but 3 doesn't go into 10, so we can't use 10. So the next term would be 20. All right, we need to ask ourselves, do 2 and 3 go into 20? Well, 2 goes into it, but 3 doesn't. So we can't use 20 as our common denominator. So the next number that 10 goes into would be 30. And we need to ask ourselves again, does 2 go into 30? Yes. Does 3 go into 30? Yes. So this 30 is our least common denominator. Is it the only common denominator? No. But it's the smallest one that we can work with. So that's what we're going to try and use. And again, the most direct way to find the common denominator is list the multiples of the largest number. So in this case, 10. So you do 10, 20, 30, 40, and so on until you find one that all the numbers go into. We're then going to use that 30, so this 3, 2, and 10 came from our fractions. We're going to take that 30 and we're going to multiply everything by it. So we're going to do 30 times 1.5 over 3 plus 30 times 1/2 plus 30 times 1.5 over 10. And since we're multiplying everything on the left by 30, we also need to multiply the right side by 30. And once again, I'll say it a couple more times. This is a very involved problem, but follow along and just try your best to grasp this. Think of this as a challenge problem and do your best. So what we need to do is we're going to multiply everything by 30 now. So 30 times 1.5, this would give us 45 over 3 plus 30 over 2 plus 45 over 10 equals 30t. And what you'll notice, I did some highlighting, so remember that 30 came from over there, we're going to highlight that in pink. Each of these can be divided now. 45 divided by 3 is 15. 30 divided by 2 is 15, and 45 divided by 10 is 4.5. So now fractions are gone, right, which makes our life a lot easier. This becomes a much easier problem to work with. And I could pretty easily add 15, 15, and 4.5, where back at this step here, 1.5 over 3 plus 1/2 plus 1.5 over 10 is not exactly the easiest problem. Are there other ways that this could have been done? Yes. But this is one of the linear ways, solving linear equations, so that's the method we're going to use in this specific example. When I add these up, I would get 34.5. That would be equal to 30t. And to solve for t, I would divide each side by 30. So t will be equal to 1.15. Now, we need to figure out, all right, what did t represent? T was the total time of our trip. So we spent a total time on this trip of 1 hour, 1.15 hours. And the question was, can she be home in 1 hour? Well, 1.15 hours is greater than 1 hour. So can she be home in 1 hour? No, it's going to take a little bit longer than that. And all of that work was just to state that no, she cannot be home in 1 hour. one last time, take your time with a problem like this. You may want to watch this video a second or a third time and just slowly go through the steps. Get an idea of things like distance equal rate times time. We go over this literal equation stuff later in the year. In a couple sections, we'll cover this in way more detail. But for now, take it as a challenge problem. Don't stress yourself out or beat yourself up if you don't really understand it right away. Ask questions, watch it a couple times, and just give it your best shot.